Hey, welcome back in this OpenCV Python image processing series. Today we dive into image transformations and effects, how to move, rotate, scale, flip, and even change the perspective of images. These operations are code to computer vision, used in robotics, augmented reality, and object detection. By the end, we'll build an interactive transformation viewer where you can control angle and zoom in real time. So let's start with our first topic today is the translation. So translation means shifting an image like sliding a photo on a table. Pixels move, but their values stay the same. So let's start this. First, as usual, I will write here import CV2, then import numpy as np. Okay, now I have to select an image here, which one I will translate. Now, by doing this type of translations, first I would like to select an image equals to cv2.imread, and then here I have some images, so I can use this one. So right here, the picture JPG. So picture JPG. Okay, now what I will do here is for translated, I need the translation metrics. So to do this, I'll write here np numpy dot float 32, and then I'll write here now the 1, 0 tx means 100 and then 150. Okay, now so here it's called it is what it will do, it will shift right the image by 100 pixel, and this will shift the image to the downside. Now what I'll do here is translated equals to cv2.warp affine, and now the image we have, and we'll apply here the translation, and then I will just simply write here image shape. So this is the row and the column. So now after this, what I can do here, the cv2 install Windows. If I run this, you can see it's moved here. Okay, now you can do this type of thing before we can define the rows and column like this. So here's another way to do this. You can write here row and column image shape. Now what I can do here is instead of all of this, I can just simply type here column and row. So now if I run this, you can see the image is shifted or translated. Okay, now we'll move to our next topic, which is rotation. We'll rotate an image. So rotation spins the image around the center point like rotating a picture frame. So first I will write here cv2, then we will write here image equals to cv2.imread, and then picture 2.jpg. Now we'll find the center here. So the center will be our which is the column of our picture. Okay, so before that we'll define the rows and columns. So rows and columns equals to im image dot shape. Now I got the rows and columns of this image in a matrix form. Now I'll find out the center of this image, which is center equals to columns slash 2 row. Now I have the center. So now what I will do here, I'll define aim equals to get rotation matrix 2D and center 45, 1. So what we're doing here, 45 means it will rotate at 45-degree angle, and 1 is the scale. It means I'm doing here no zooming. Now after that, rotated equals to CV2 on columns. I'm sure the rotated image wait key, and let's run this. You can see the image has rotated. So this is how you can rotate an image. Now you can change this, like if I want to rotate it at 90-degree, I can just simply change here and run this, and you can see the image has rotated 90-degree angle. Okay. Now let's move to our next topic, which is scaling. Okay. So we're taking the same image. Now make a variable scaled equals to cv2 dot resize. Now image comma none comma fx equals to 1.5, fy equals to 1.5. Okay, now small equals to, okay, now what we can do here is, okay, so now what I have done here, that fxy and fxx, they're the scale factors. So when the value is more than 1, it is mean it is zooming in, and when the values are below 1, it means zooming out. So what I'll do here is scaled. Now another one is zoom out and CV wood key and destroy the all windows. Now if I run this, you can see two images. This one is the zoom one, and this one is zoom out. This is the small one, this is the scaled one. So this is how you can make an image scale bigger, and this is how you can make smaller. Okay, now let's move to our next topic, which is flipping. Flipping creates a mirror effects, horizontal, vertical, or both. So let's see how we can do this. So first we'll make here h equals to cv2 dot flip image, and then v equals to flip image 1, and if I go here for both, this is for both, for horizontal and for vertical, for both I have done this. Now cv2 show here. Now if I run this code, you can see here this is the vertical flip, this is the horizontal flip, and this is both. Okay, so what happened here? This is a vertical flip, a mirror on the right side. This is the horizontal, is the both flip, and this is the horizontal flip. So this is how you can flip an image. Now we'll move to our next topic, which is affine transformation. Affine transformation lets us skew or stretch the images. Parallel lines remains parallel. So how we can do that? Let's start with this and First we have to import here numpy, import numpy as np, and now we have here the pts equals to np dot float 32, and we can make this kind of 50 comma 50, and let's erase this, and we have the pds one, which is this, and then we can make here an m equals to cv2 dot up cv2 dot get affine transform pds comma pds1, and we can write here affine equals to cv2 dot verb affine verb cv2 dot verb affine, and then image columns and rows. So I have to define here the rows and columns before that. To do this, I'll write here rows and columns equals to image shape, and we can write here 0 2. Okay, I don't need this, so it's the image dot shape, and I can write it here. After that, what we'll do, we'll just write here cv2 okay. Now let's see what actually happens here. Okay, some mistakes I have done. Okay, sorry. So what I have to do here is columns and rows image dot okay, sorry, I made a mistake here. And now let's run this, and you can see the image is traced and also transformed. So you can see this is how we can do the affine transformations. Okay, now let's move on to next topic, which is the perspective transformation. So perspective transformation changes viewpoint like tilting a document. So just like that, what we'll do here, we'll do some changes on this line. These three lines will be changed. So here what we'll do, we'll make it 0 and 0, and we'll make here the columns and then 0. We'll make it here rows. Okay, we'll make it here like columns, and we'll do it here rows, and here I'll do make it 50, and this one is also 50, and columns minus 50, and make it 0, and we'll do 0 column 0. I will make here another row, which is okay. So we need 4 variable here. So what we'll do here is make another one where I'll 0 comma rows, and here we have 0 comma rows, so we can here 0, and we can put here the rows, and we can here the column. Okay, we don't need here minus 50. I have the columns, so that rows minus 50. Okay, now transformation, instead of affine transformation, we'll write here the perspective transformation. So let's write the perspective transformation, and now instead of verb affine, we will write here perspective. So perspective cv2 dot verb perspective image m, and we'll write here instead of this, we'll write here perspective. Okay, Okay, done. Now let's destroy CV to the destroy all windows. Now let's run this one. You can see the image has tilted. So now I'll explain what actually we have done here, that we have 2 points have taken. One is like you can see from this is the 0 point, and then the columns from the 0 side, and the columns is minus 50 pixels. And we took here the 4 sections so that we can tilt and also stretch the image. Okay, now let's move our next topic, which is image pyramids. So pyramids create multiple resolutions of an image, important for detection. So how we can do that? So for this, let's remove this one first, and okay, this one deleted, and let's make down equals to CV2 pi down image, then up pi up, and show original, and show down, and show up. Okay, now let's run this, and you can see this is the down, this is the up, this is original. So what we have did, we have created multiple resolutions of an image. So sometimes we need to blur something in our image. We need less resolution on the background, but much more in the in front, so where we are standing. So this is how we can change the resolution of an image, or you can also change a particular part of an image. Now let's do our final project, an interactive transformation viewer. Let's build something powerful, an interactive viewer. You can change angle and zoom using slider. Okay, so how we can do that? So let's start from here. Okay, now first what I'll do, I'll make here a function def nothing x pass. Okay, now cv2 dot name window is transform, and then I'll make here cv2 dot create trackbar, and I'll name it as angle. Okay, angle, and then I'll create here cv2 dot trackbar scale. Okay, now while true angle equal angle cv2 get trackbar pause angle transform, then the scale. Now rows column image shape, now rows column image shape. Now we need to rows column, then we need the center, right? So here is the center for the rotation angle, and then it's the angle and the scale, and we have warp affine. Okay, so what actually we'll do here is first understand how the rotation will work. So in before we have seen here, in case of rotation we give here the center, so we have done this here, an angle and the scale. So angle and the scale will be in the trackbar, where the values are from 0 to 360 and the scale is from 1 to 10. Okay, now after that I can write here, and at the end we can write here cv2 destroy windows. Now let's run this and see if it still works or not. Okay, so this is the image we have. Now if you want to change the angle, by changing the value it will rotate, just in like your software we used in our editing. And for scale, as the value is changed, it will zoom in and zoom out. Okay, so this is how we can make the editing softwares, photography editing softwares, or anything you see in the mobile phones or Photoshop. This is the background and how actually images are transformed. So this was the video today, and in this video you learned how to transfer images using OpenCV Python from translations and rotation to perspective and pyramids. In the next video, we'll explore more new concepts on OpenCV.